This is a lesson on equilibrium. The real stuff, big boy pants equilibrium. We have the equilibrium expression as always, like hydrogen plus fluorine gives you 2 hydrogen fluorides. Let's say the K value in this case is 1.15 times 10 to the negative 6. And original concentrations of hydrogen is 1 molar. Fluorine is 2 molar. And HF is 0. Do our ice table. Initially, you have 1, 2, and 0. Obviously, it's going to shift to the right, so you're going to, mole ratio, lose 1x, but there's a 2 here, so you gain 2x. So our equilibrium concentrations are 2x, 1 minus x, and 2 minus x. Write our K expression, 1.15 times 10 to the negative 6 equals, right over left, 2x squared over 1 minus x times 2 minus x. Fortunately, this time you can't take the square root of both sides. It won't work. So the only thing we do here is to distribute and come up with an equation. And if we do that, we end up with cross multiplying 4x squared equals 1.15 times 10 to the negative 6 x squared plus, or minus 3.45 times 10 to the negative 6 x plus 2.3 times 10 to the negative 6. Combine like terms, shift it over, you get something like 3.9999 if you subtract that from 4x squared, so let's just call it 4x squared plus 3.45 times 10 to the negative 6 x minus 2.3 times 10 to the negative 6 equals 0. Plug that into your quadratic equation or quadratic solver and plug in the values, and you get x equals 7.58 times 10 to the negative 4. Plug those back in up here, and you get 0.9999242, 1.9999242, and double that, 0.001516. Now, doing significant digits, even 2 or 3 digits, this is going to run off to be 1. This is going to be running off to be 2. And this 3 significant digits, 0.00152. If you notice, those, if we ignore the x, turn out to be the same thing. And that leads us to the assumption. And that is, if the K value is much smaller than 10 to the negative 4 of the concentration. The smallest concentration is 10 to the negative 4 times greater than the K, where the K is a power of 4 off of the concentration. Then ignore any plus or minus x. You cannot ignore the doubling, the multiplication. You cannot ignore that. If you say that's 0, then you obviously won't get an answer to the original conditions. So if we did this problem up here, ignoring the x, you'd end up with 1.15 times 10 to the negative 6 equals 4x squared over 2. Solve that problem, and you'll get x being 9.29 times 10 to the negative 4, which is darn close to the actual value of 7.58 times 10 to the negative 4. And if we look at the difference between those, that's still 1. So the concentration H2 is 1 molar because it doesn't change very much. Concentration F2 is 2. Again, if you take 0.000929 away from 2, you end up with 2 rounded off, and multiply that back in, and you get something like 0.0018 molar. And that is what we call the 5% rule. If this number here is 5% of this number when you subtract it, then you can get, then you can call it good. The smallest concentration is 1. Smallest concentration 1. And is that 5%? What's 5%? 0.05. Is this smaller than 0.05? Yes, we're good to go. Another example of using the assumption. If we have 2 NOCl equilibrium, 2 NO plus Cl2, where K is equal to 1.6 times 10 to the negative 5th. In our original concentration of NOCl is 0.50 molar. 5%, or 10 to the negative 4, we move the decimal point over, we're within range, so we can make that assumption. So the assumption is good. So ice table. Originally we have 0.50, 0, and 0. This side has to get smaller by minus 2x. This side gets bigger by plus 2x and plus 1x. 0.5 minus 2x, 2x, and x. Now, we're going to make the assumption that any additions or subtractions of anything that can turn, any term that contains an x is 0. And go. The concentration, the K value is K 1.6 times 10 to the negative 5th equals 2x squared times x divided by 0.5. So that would be 4x to the third equals 8 times 10 to the negative 4, cross multiply, divided by 4. 2 times 10 to the negative 4 equals x cubed. X equals 0.0585. And that is close to the 5%. So our assumption is good. So we're good to go. So x is that. So if we take away 0.05, that's fairly in the margin. 5% of 0.5 is 0.025, and we'll call it good. So our final concentration is 0.5. 2 times that is 0.117, something like that, and 0.0585. Well, you say, well, that's kind of iffy, maybe you shouldn't do that assumption. Well, what would you do? Let's do the problem without the assumption. You would get 1.6 times 10 to the negative fifth equals, the top stays the same, there's no assumptions going on, so that's going to be 4x cubed over 0.5 minus 2x squared. So you multiply that out. Multiplying this out and cross multiplying, you would end up with 1.6 times 10 to the negative fifth times the quantity 0.25 minus 2x plus 4x squared equals 4x cubed. Now, even if we distributed this out in the end, you can't do the quadratic formula because it's to the third power. There is a way of doing this using your graphing calculator. Underneath y equals, y sub 1 equals 4x cubed, y sub 2 equals 1.6 times 10 to the negative fifth, 0.25 minus 2x plus 4x squared, and solve those equations simultaneously. You will get 1 point on the positive side of x, positive side of the origin. That will work. Unfortunately, you can't use your graphing calculator on the AP exam. That concludes this lesson on the full-blown big boy pants equilibrium problems.